Good afternoon, everyone. My name is Mike Enix, National Sales Manager for Techniks. On behalf of everyone here at Techniks, I'd like to welcome you and thank you for attending today's digital trade show. The purpose of the digital trade shows is just like any traditional trade show. We're going to share some new technology and also provide you a forum to interface with industry experts on relevant topics. We encourage you to ask questions. We've got some folks standing by to answer any questions that you might have. There's a chat box on the right side of your screen that allows you to ask questions. If that's not present, click on the green bar on the top of your screen and the chat bar should appear. We'll respond to as many questions as we can throughout the presentation and then follow up on any other questions we have immediately following. If you miss any portion of today's presentation, there will be a recorded version out at www.techniksusa.com. Today's presentation subject is tapping. We're going to talk about how to improve tap life, part quality, and improve overall production and productivity. I'd like to first start with a cost-saving example. We met a fellow at IMTS that does aerospace parts out in California and had complained about tap life and also part quality. He was using an ER rigid collet and ER collet chuck on a Morisiki and 304 stainless, and again came to us with kind of a challenge to increase his tap life. We applied one of our new technologies that we were launching at IMTS called Microfloat, and we were able to solve his problem to the tune of about 295% improvement in tap life, which also improved his overall productivity due to much less machine downtime via tool changes. Today's agenda, we're going to talk about common tapping issues. What are some of the challenges that people face in tapping? And then we're going to talk about three specific technologies, what I would call standard technology, ER collets, both rigid, quick change, and floating collets. We'll also talk about quick change tapping systems. And lastly, we'll talk about our new Microfloat tapping system. One of the biggest challenges with tapping is it's the only machining operation where feed rate and spindle speed have to be perfectly synchronized. If you change one parameter, the other must change with it. So not only that, but for every revolution that the tap makes, the tap must advance on pitch. That makes tapping much more challenging than, say, drilling or end milling, where those parameters don't have to be synchronized. So what is rigid tapping? Basically, rigid tapping is the machine's ability to synchronize those two functions, spindle speed and feed rate. The way that happens is microprocessors within the CNC control monitor the spindle speed and then automatically adjust feed rate to keep those two synchronized. Another challenge with tapping, and one of the biggest issues that we hear about constantly, is tap wear. So there's really two issues with tap wear. One is tap holders that don't have any radial float restricts the tap's ability to follow a drilled hole. So if the tap is not concentric or does not have radial float, it'll not follow the drilled hole. It wants to cut more like an end mill than it does a tap. Creates a lot of wear on the flank of the tap. The other issue is with axial compensation. If there's no axial compensation in a tap holder, it's going to create wear at the point where the tap enters the workpiece, and then even more so when the spindle reverses and feed rate changes direction. This chart shows exactly that. What the line indicates, this is on an ER rigid tap collet, which would have no axial compensation. This is really a measure of force on the tap on a tool holder and set up with no axial compensation. You can see along the line here that actually there's less stress or force on the tap at the point where it's doing its cutting. So as you're cutting threads, there's not an awful lot of force on the tap. The force is created at the point where the spindle reverses here, and as the tap is retracted from the hole. That's where most of the stress occurs on the tap. Even with rigid tapping, there are still synchronization errors. In other words, even though rigid tapping is supposed to synchronize the feed rate and spindle speed, it's not an exact science. As machines wear out, as the spindles wear out, there's still a gap that's created, or call it slop in the spindle, again at that point where the spindle has to change directions and feed rate changes direction. You also have pitch tolerances on the tap itself. In other words, there's tolerances built in, or the tap is not always made perfectly. Therefore, that can create wear on the tap as well. The first technology we're going to talk about is tapping with ER collet chucks. The first collet that's commonly used with ER is the rigid tap collet. The benefit of this technology is that basically you're able to take an existing collet holder, drill, ream, tap. You have a multifunctional tool. It is not a dedicated tool the way a tapping head would be. The way this works is there's larger slots in a regular ER collet that lock the square and the tap in place. There's a tremendous amount of radial torque that's put on taps, especially as they wear out, and those larger slots will lock the tap in place and prevent rotation. You also have coolant through capability with the ER tap collets, and again, you don't need dedicated tapping heads, so it's a very economical alternative to having to buy dedicated tapping heads. This here shows a coolant through application with ER tap collets. There are more and more prevalent these days are coolant through taps. The photo here shows the ability to run coolant through a tap by matching our coolant ring system with the shank diameter of the tap. We also have the ability to oversize the coolant disc, run coolant down the shank and along the cutting edge if it's not a coolant through tap. This is going to be valuable for chip evacuation and, again, longer tap life, especially when tapping a deep hole. The drawbacks to the ER system, there's no axial compensation. We talked about that float in a tapping setup. There is no axial compensation with this particular ER rigid collet. So you're going to have wear on the tap again at entry and upon reversing the tap. There's also no radial play with an ER collet. So if it's not concentric, it's going to restrict the tap's ability to follow that drilled hole and create excess wear on the tap. Both of these things will result in poor thread quality and decreased tap life. Also, on this particular style ER collet, there is no quick change feature. Every time you would change a tap, or every time you would change a tap collet, you'd have to break it down, go back to the locking fixture, and to tool change. So not very productive, more spindle downtime. The two other types of ER collets that are available for tapping are quick change, which is the collet on the top. There's a quick change mechanism here. As you depress that, it allows you to extract the worn tap, put in a new tap, and you're off and running. You don't have to take the nut off. That can be done right at the machine. So again, more productivity with an ER collet system. Also, there's floating ER collets that can be used with collet chucks that are an economic alternative to floating tap heads. Floating tap holders can get fairly costly. The one limitation with the floating tap holders is they only have compensation in one direction. So they're not designed for use with conversational programming or canned tapping cycles. In other words, you have to be able to program independently feed rate in and feed rate out. If you're not able to do those two things, then this is not the collet to use. The next technology we're going to talk about is quick change tapping systems. These offer you the ability to quick change not only the collet, but also quick change the tap. So the fastest in terms of tap changeover, and also if you're running different size taps, the ability to change those collets quickly. There's a wide variety of collet sizes available, both in inch and metric, and this system also allows capacity for larger taps, much larger than what the ER system allows for. The first quick change system that's out there are rigid tap holders. Now these are going to be used with rigid tapping cycles. Okay, so if you're running rigid tapping, this is the holder to use. Again, you have the ability to quick change both the collet and the tap. You also have coolant through ability with these holders. And you do have a slight amount of radial play, which is going to, again, allow that tap to follow the drilled hole. These holders give you the ability to run up to a 1 7/8 tap capacity, again, much larger than what the ER system would allow. Drawbacks of the rigid tap holders: no axial compensation on the rigid system. Again, increased tap wear. If that holder does not have the ability to float, it's not going to allow the holder to pull the tap into the hole on pitch. And again, also where we saw all that stress on the tap at the point of spindle reversal. They are more expensive than ER chucks and collets. And again, this tool is going to be dedicated in its function. It does not have the ability to drill or mill or ream. It is a tapping head, and that's all it can do. Unlike an ER holder that's going to be a lot more versatile. Tension compression style holders. These holders offer the ability for the tool to float in both directions. The compression stroke that allows the cushions the tap upon entry to the workpiece, allows the tap to pull into the workpiece or into the hole on the pitch of the tap. That's important. Also, the tension, the extension or tension function of this chuck will allow that to engage at the bottom of the hole upon spindle reversal and extraction of the tap. So it's essentially what it's going to do is it's going to take up any play or slop in the spindle. Now, tension compression holders are used typically in traditional tapping cycles, not with rigid tapping. So that's one of the things that often people get confused about is, can I use this with rigid tapping? They're not designed for rigid tapping. The reason for that is there is an adjustable compression feature that does not entirely lock out the compression, but it will make the holder, it'll make it harder for the holder to compress. However, that cannot be locked out entirely, and you have up to as much as 595 or 590 thousandths of float in either direction. So as the tap bears and there's more force on that tap, you can have a large amount of float, which makes it difficult to control thread depth. So again, not typically used with rigid tapping. The different type of tap adapters that are used in quick change systems. You have rigid tap collets, pictured here, as well as the clutch drive tap collets. There's some confusion as to when you would use each technology. So if you're tapping a blind hole, typically you want to select the clutch drive tap collet. Okay, what that clutch mechanism is going to do is if the tap reaches the bottom of the hole, the clutch will engage, allow you to extract the tap without breaking the tap. Most of the taps you break are at the bottom of the hole. We all know that. If you're tapping a through hole, you want to use rigid tap collets. Not necessary to employ the clutch technology. If it's a deep through hole, you want to use probably clutch drive. It's kind of an either-or situation. But a lot of times a tapping operation is one of the last things that's done to a part. And if you're tapping a deep hole, you can't afford to damage threads or have the opportunity for a scrap part. So probably best to use a clutch drive tap collet in that situation. A little more margin for error. Both style collets can be used with rigid or tension compression adapters. The last technology we'll talk about is the microfloat. Well, why is microfloat even needed if you have rigid tapping? Well, rigid tapping, as we talked about, is not an exact science. So as the machine wears out, there are still errors as the ball screws in the spindle wear out. So there's still a gap or a certain amount of slop in the spindle, even with rigid tapping. That creates unnecessary thrust loads or stress on the tap due to that error. Rigid systems often don't have any radial float that also lead to increased tap wear. This leads to tap breakage issues, premature tap wear, machine downtime, and again, tapping being one of the last operations makes scrapping parts really unaffordable. Benefits of the microfloat system, like we saw in the case study, dramatic improvement in tool life, a guaranteed tolerance of threads, less broken taps, still gives you the ability to run coolant through. Tapping is much faster and much more productive with rigid tapping than a traditional tapping cycle with a tension compression holder. This gives you the ability to quick change the adapters and the tap as well. It's a modular system, so it does allow for long reach or hard to reach tapping operations. How does this system work? Well, basically, unlike a floating or tension compression holder, you have a very small amount of compensation in each direction. 0.008 of compression ensures that you're going to pull the tap into the workpiece on pitch. 0.040 of tension is going to account for that small amount of error that still exists with a rigid tapping cycle. So at the point of spindle reversal and drawing the tap out of the hole, there's 0.040 of tension that will engage with that holder. This is the same chart we looked at earlier that shows stress on the tap. Again, the black line being an ER collet chuck, so no axial compensation. The red line being our microfloat tapping holder. So this shows the stress at the point, less stress at the point the threads are cut, and way less stress at the point of spindle reversal and drawing the tap back out of the hole. So imagine the decreased wear on that tap versus the stress that's created with an ER. That's the reason for such dramatic results as I showed you earlier. Again, the microfloat also offers the ability to build up a modular system through the use of extensions. So if you have difficult to reach tapping applications, the system will allow for a modular setup for long reach applications. This is another case study that we did with a gentleman making stamping dissections in D2 tool steel. He had used a rigid collet as well, an ER rigid collet, had actually tried a competitor's what they call a synchro holder, which also offers a very small amount of compression and tension, and then tried our microfloat. So even though the technologies are similar between the synchro holder and the microfloat, because of the accuracy and the concentricity of our microfloat setup and the spring mechanism that we use to create that float, we were able to actually increase tool life even over our competitor's synchro holder, and about an 85% increase versus the ER rigid collet. To summarize, tapping is a challenging machine operation. Even with modern CNC machines that have rigid tapping, it's an inexact science. Results in premature tap wear, broken taps, machine downtime. We have a lot more parts that are rejected or scrapped due to poor thread quality. ER collets can provide a very versatile option and a low cost alternative to expensive tapping heads, although the rigid setup doesn't always address issues with tap wear. The quick change tapping systems are very productive from the standpoint of changing tools. However, the rigid holders also don't account for that spindle error as they lack axial float. The tension compression holders, although good, are not for use with rigid tapping cycles, which most machines now possess. Microfloat, really the best of all worlds. It's the best system for rigid tapping. It accounts again for that spindle error with moderate axial compensation. It still gives you the coolant through capability for optimal chip evacuation and increased tap life. And again, it has modular setup for long reach tapping. Do you have any issues with rejected parts due to poor thread quality? You do a lot of tapping? You have issues with break-in taps or scrap parts? Do you have an issue with spindle downtime as a result of changing taps for tap breakage? Are you interested in general in evaluating a more productive and accurate tapping system? Well, if so, Techniks would love to help. One of our experienced sales engineers is available to answer any questions that you have. We'll follow up, and we would love to arrange a no-risk product evaluation for you if tapping is something that you'd be willing to consider. Thanks again for your time. Thank you for your interest in Techniks products and your participation in today's digital trade show. Thank you.